it will be moving relative to Earth at nearly 100 kilometers per second when it's closest to the sun.
Harvard astrophysicist Avi Loeb has suggested the 3-Eye Atlas is actually some type of alien technology.
The announcement that Harvard researchers and NASA analysts are closely monitoring the newly discovered interstellar object designated 3-Eye Atlas has electrified the scientific community and raised global concern. Unlike past interstellar visitors such as Oumuamua or 2I/Borisov, this particular body carries with it the unnerving possibility of a near-future impact on Mars. The notion that an object originating from outside the solar system could intersect so dramatically with one of our closest planetary neighbors is nothing short of extraordinary. The data, though still under refinement, has already been described as terrifying in its implications because of both the size of the object and the velocity with which it is traveling. Before we start, smash the like and subscribe buttons for more updates. The path of 3-Eye Atlas has been reconstructed through meticulous observation, and what alarms scientists most is the convergence between its projected orbital trajectory and the orbit of Mars. Harvard astrophysicists working in tandem with NASA's Jet Propulsion Laboratory have fed weeks of telescope data into advanced simulations, and the models consistently place the object on a collision course with the red planet within the next few years. The odds are not yet absolute, but the margin of error is narrowing, and even a small probability of impact is sufficient to warrant serious attention. Mars, with its thinner atmosphere and barren surface, offers little protection against an object of this scale, meaning the collision could alter the planet's landscape in profound and lasting ways. The object itself is remarkable. Early spectroscopic analysis reveals that 3-Eye Atlas is composed largely of volatile rich materials, similar to icy bodies from the farthest reaches of the solar system. Yet its trajectory confirms it originates from well beyond. It is not bound by the gravitational architecture of our planetary system, but is instead a true wanderer of interstellar space. Its sheer velocity confirms this origin. Traveling faster than any asteroid native to the solar system, it carries kinetic energy orders of magnitude higher than what we typically model in planetary defense scenarios. A collision with Mars would therefore unleash a force rivaling the most catastrophic impacts in recorded planetary history. The scale of devastation on Mars would depend on the precise size of the object. Early estimates suggest a diameter in the range of 1 to 2 kilometers, placing it squarely in the category of planet-shaping impactors. If this is accurate, the crater left on Mars would dwarf most visible craters on Earth and potentially rival structures like Hellas Basin, albeit on a smaller scale. The energy released in such an impact would be equivalent to millions of megatons of TNT, creating shockwaves that ripple across the Martian crust, lofting enormous amounts of dust into the thin atmosphere, and potentially altering weather patterns for decades. Even without an atmosphere capable of sustaining life as we know it, the impact could profoundly change the planet's climate dynamics and surface geology. NASA and Harvard scientists are particularly interested in the implications for ongoing and future missions to Mars. Humanity has invested billions of dollars in rovers, orbiters, and the dream of crewed exploration. If 3-Eye Atlas strikes near areas where robotic assets are deployed, it could destroy years of accumulated scientific work in an instant. A strike in regions of particular geological interest, such as near the Jezero crater or Valle Marineris, could erase or dramatically reshape landscapes that are central to our understanding of Martian history. For agencies planning human exploration, the potential impact raises serious questions about mission timelines and priorities. Would it be wise to send humans into a system where a massive interstellar object is on a destructive path? Or should missions be accelerated, aiming to study the planet before it is irrevocably changed? There is also the tantalizing scientific opportunity that such an event presents. Impacts of this scale do not occur often, especially not ones involving interstellar bodies. Should 3-Eye Atlas collide with Mars, it would offer humanity a front-row seat to a planetary-scale experiment. Observatories on Earth and orbiting platforms could track the event in real time, measuring everything from ejecta plume composition to seismic activity on Mars. This data would be invaluable for understanding how planetary surfaces evolve under high-energy bombardment. Furthermore, Studying the materials from 3I Atlas itself could provide the first tangible samples of interstellar chemistry delivered directly to a planetary surface, albeit under violent circumstances. Despite the scientific allure, the risks dominate the conversation. The possibility that Mars could become an entirely different world overnight is sobering. Craters, after all, are permanent records of violent encounters, and Mars is littered with them from its early history. But unlike those ancient events, this one would happen before the eyes of modern science, and in the era of space exploration, where Mars is no longer just a distant world, but an emerging frontier for humanity. The destruction of potential landing zones, habitats, or resources that future astronauts might rely on would be a setback of historic proportions. Moreover, the psychological impact of watching a neighboring planet endure such a cataclysm cannot be underestimated. For many, Mars represents a symbol of hope, a backup world for humanity's ambitions. To see it scarred by a cosmic intruder could shift public perception of space exploration itself. The conversation among planetary defense experts is already shifting. While much attention has been focused on protecting Earth from asteroids, the 3I Atlas situation underscores that planetary defense must be a solar system-wide concern. If Mars can be struck by a wandering interstellar body, the randomness of such events reveals the limitations of current surveillance. Telescopes caught 3I Atlas only recently, despite its enormous size and velocity. This has renewed calls for expanding sky survey capabilities, building more sensitive instruments, and stationing observatories beyond Earth's orbit to widen the net of detection. Harvard's team in particular stresses that humanity is still dangerously blind to objects hurtling toward us from the void. The potential impact also reignites debate about the long-term survival of humanity. While Earth is not in the direct line of fire, the spectacle of an interstellar body striking Mars is a reminder of cosmic vulnerability. The Earth has its own scarred history, from the impact that likely killed the dinosaurs to smaller events like Tunguska. Seeing Mars transformed in real time could galvanize political will to invest in planetary defense systems, such as kinetic impactors or even more exotic technologies like directed energy systems. Harvard astrophysicists argue that 3I Atlas should be seen not only as a Martian crisis, but as a warning to Earth, a demonstration of what is possible when interstellar wanderers stray too close. For the Mars research community, the looming threat presents a strange duality of dread and anticipation. On one hand, the possibility of decades of work being obliterated is devastating. On the other, the data generated from such a collision could rewrite textbooks on planetary science. NASA's Mars Reconnaissance Orbiter and other assets in orbit would be positioned to record unprecedented detail of the event, from the moment of atmospheric entry to the formation of the crater and aftermath. These observations would complement Earth-based telescope data and could potentially yield insights into the composition of interstellar bodies, as fragments lofted into space may be recoverable by spacecraft. The geopolitical dimension cannot be ignored. Space agencies worldwide are already coordinating, sharing telescope time and refining models. But the potential impact also raises the question of how humanity prioritizes resources. Should funds earmarked for long-term Mars colonization projects be redirected to short-term observation and analysis of the impact? Should international missions to Mars be accelerated in the years leading up to the possible collision in order to maximize science before the landscape is altered? These questions are pressing, and the answers will shape the trajectory of interplanetary exploration for decades. From a philosophical perspective, the idea of an interstellar object striking Mars is profound. It is a vivid reminder that planets are not static or isolated. They are constantly influenced by forces beyond their control. Humanity often speaks of terraforming Mars, of reshaping it to suit human needs. Yet here, nature itself may terraform the planet in a single violent act. The scale and speed of cosmic change dwarf human ambition, underscoring the fragility of our plans in the face of universal forces. Harvard scholars reflecting on the event emphasize that it challenges not only our science but our worldview, compelling us to acknowledge the precariousness of life and civilization against the backdrop of an indifferent cosmos. The potential collision also sparks new debates about contingency planning. If 3I Atlas were on a trajectory to strike Earth, the timeline for preparation would be desperately short. Mars offers a kind of trial scenario, a chance to observe how agencies, scientists, and the public respond to the knowledge of a catastrophic impact. The coordination, communication, and allocation of resources in this case could serve as a rehearsal for the day when such an object heads directly toward Earth. Some argue that this may be the greatest lesson 3I Atlas has to offer, a real-world test of humanity's readiness for the ultimate cosmic threat. As telescopes continue to refine the orbit of 3I Atlas, the tension only grows. Each update narrows the range of possibilities, and though the final outcome is not yet certain, the weight of probability leans toward collision. The idea of standing on Earth and watching, perhaps through live streams from orbiters, as Mars is reshaped by an interstellar bullet, is at once terrifying and awe-inspiring. It is a reminder that our solar system is not a quiet neighborhood, but a dynamic, hazardous arena where chance encounters can have world-changing consequences. Whether Mars emerges with a new crater or narrowly escapes destruction, the passage of 3I Atlas will leave an indelible mark on science, exploration, and humanity's imagination of the cosmos. The approach of 3I Atlas has created a new landscape in how humanity perceives both the solar system and interstellar space. Every hour of observation adds to the mounting tension, not because Earth is immediately threatened, but because Mars stands as a proxy, a visible demonstration of what happens when a foreign body from beyond our system intrudes into the orbits of our neighboring worlds. The more scientists study this object, the clearer it becomes that its arrival marks a turning point in planetary science and exploration. No simulation or classroom lecture could ever replicate the scale of the implications. A living example of interstellar chaos is racing toward one of the most studied planets in human history, and the world can do little but watch and prepare. The classification of 3I Atlas as the third interstellar object ever detected makes it scientifically extraordinary before any discussion of impact probabilities. Unlike 1I Oumuamua, which slipped past so quickly that observations were frustratingly limited, or 2I/Borisov, which presented a more traditional comet-like appearance, this body has the potential to interact directly with a planet. That alone elevates it beyond a curiosity into a phenomenon of historic proportions. Harvard researchers stress that observing an interstellar body colliding with a planetary surface could be compared to the first telescopic observations of Jupiter's moons, an event that forever altered humanity's perspective of its place in the universe. The difference now is the destructive force involved, and the immediacy of the event. Instead of simply expanding knowledge, it threatens to overwrite existing frameworks about planetary evolution and cosmic vulnerability. Astronomers are fascinated by the object's trajectory not only for what it implies for Mars, but for what it reveals about the Milky Way's broader dynamics. Interstellar objects like 3I Atlas are likely fragments of planetary systems long since dismantled, expelled by the gravitational turmoil of their parent stars. This means 3I Atlas could carry within it the chemical fingerprints of distant worlds, perhaps formed under conditions wholly unlike those in our solar system. If fragments of the object survive the potential collision and can be studied remotely, scientists may, for the first time, directly sample the geology of another stellar system. Such a possibility electrifies the research community, since it would provide evidence about whether planetary formation is a universal process, or if unique pathways exist depending on the stellar environment. The sheer velocity of 3I Atlas adds another layer of intensity. Objects from interstellar space travel at speeds much greater than local asteroids because they are not constrained by the gravitational equilibria of the Sun. Instead, they carry with them the slingshot energy of their distant journeys, barreling across interstellar voids with momentum accumulated over millions or even billions of years. This means that when they encounter planets, their kinetic impact is amplified dramatically compared to solar system asteroids of similar size. Harvard simulations emphasize that even a modestly sized body from interstellar space can deliver devastation out of proportion to expectations. This is one reason why the language around 3I Atlas has been so stark. Calling the data terrifying is not hyperbole but a reflection of the object's extraordinary destructive potential. Mars itself, already a world defined by colossal impact scars, could serve as a natural laboratory for understanding the consequences of such high-energy events. Craters like Hellas, Argyre, and Isidis basins, are testimony to its violent past. But these are ancient, their formation shrouded in deep time. A modern event allows scientists to compare past with present, measuring whether existing models of crater formation align with real-world outcomes. The dust dynamics alone could teach us more about Martian atmospheric behavior than decades of slow observation. Dust storms on Mars are already among the most dramatic weather phenomena in the solar system, sometimes shrouding the planet for months. A fresh injection of material from a massive impact could trigger storms of unprecedented intensity, providing new insight into the interplay between surface and atmosphere. Beyond science, the psychological and cultural dimensions of this event are vast. For centuries, Mars has been a canvas for human imagination, the home of fictional civilizations, the stage for utopian colonization, the next great step in humanity's expansion. The possibility of watching it transformed by a cosmic intruder forces a reevaluation of these dreams. Would Mars still hold its symbolic power if it were dominated by a fresh planet-altering crater? Would the romance of colonization be overshadowed by the reminder that it is as vulnerable to interstellar catastrophe as any other celestial body? Philosophers, historians, and artists are beginning to grapple with what it means to witness planetary violence on such a scale in the 21st century, when humanity has just begun to imagine itself as interplanetary. The role of technology in this unfolding drama cannot be overstated. Telescopes that identified and tracked 3I Atlas are the product of decades of incremental improvement, and yet the discovery still came late in its approach. This has reignited debates about how prepared humanity truly is to detect and monitor incoming objects. Dedicated survey projects, such as those relying on wide-field optical and infrared imaging, are increasingly seen not as luxuries but as necessities. The case of 3I Atlas underscores the urgency. What if the target had not been Mars but Earth? The thin buffer of time between detection and potential impact demonstrates just how blind we still are to the broader galactic environment. Harvard's public statements emphasize that the current infrastructure for detecting interstellar bodies is inadequate and must be expanded dramatically if humanity hopes to protect itself in the future. Mars's unique place in exploration planning adds further layers of urgency. Multiple space agencies are eyeing the late 2030s as the time frame for potential human landings. An impact event in the years leading up to that timeline could rewrite strategies entirely. If 3I Atlas strikes a region of high interest, such as near ancient lake beds believed to harbor evidence of past life, the event could obliterate crucial geological records. Alternatively, it could expose fresh material from deep underground, ironically advancing the search for biosignatures. The possibility that an interstellar collision might reveal subsurface chemistry excites astrobiologists, who argue that the chaos of impact could also be an opportunity. Material ejected into space by the collision might even be sampled by future spacecraft, offering insights into Martian geology otherwise unreachable by drills or rovers. The collision scenario raises technical questions about engineering as well. How resilient are current rover and orbiter systems to a planet-wide shock event? Would satellites orbiting Mars survive the blast waves and debris plumes lofted into orbit? Could communication networks linking Mars to Earth withstand disruptions caused by electromagnetic surges or dust interference? Engineers at NASA are already running simulations to model these contingencies. If systems fail, data about the event could be lost at its most critical moments. Redundancy in observation is therefore paramount, leading to proposals for independent probes stationed at Lagrange points or even positioned around the Moon to watch Mars from a stable vantage. The educational dimension of 3I Atlas is equally compelling. For students and the public, the idea that a rogue body from deep space could crash into a neighboring planet transforms abstract concepts into tangible reality. It demonstrates vividly that cosmic mechanics are not distant curiosities but active processes unfolding in our backyard. The spectacle of impact, if it occurs, could galvanize interest in astronomy, physics, and planetary science for a generation. Schools worldwide are already incorporating discussions of 3I Atlas into their curricula, framing it as a real-time example of why scientific literacy and investment in research matter. The ability to observe cosmic events not only enriches human understanding but could one day safeguard human survival. The cultural ripple effects will be profound. Humans have always looked to the heavens for meaning. interpreting comets and meteors as omens. Though today's interpretations are scientific, the primal awe remains. An interstellar collision observed in real time will enter mythology alongside the greatest astronomical events in human history. Unlike eclipses or meteor showers, which inspire wonder but little fear, this event carries a visceral reminder of cosmic fragility. Art, literature, and film will undoubtedly respond, capturing both the dread and the grandeur of watching a planet reshaped before human eyes. The narrative of Mars as a peaceful, waiting frontier may give way to a new story. Mars is a reminder of the universe's indifference to human ambition. Geologists see the event as a chance to test hypotheses about shock metamorphism, the transformation of minerals under extreme pressure and temperature. Laboratory experiments can only approximate the forces involved in a kilometer-scale impact, but Mars may soon provide a natural demonstration. Minerals like quartz, olivine, and feldspar could be altered in ways that reveal new information about planetary crusts under stress. These changes would be visible from orbit and possibly detectable through spectroscopy. Such studies could help refine methods for identifying ancient impact sites not only on Mars, but across the solar system, deepening understanding of planetary evolution. Astrobiologists, meanwhile, are contemplating how an impact might influence any hypothetical microbial life sheltered underground. While Mars's surface is barren, some scientists hold that subsurface aquifers or briny streaks might still harbor microbial ecosystems. A violent impact could sterilize broad regions, but also expose pockets of previously hidden material. If spores or organic molecules were blasted into space, orbiters might detect them, offering unprecedented evidence about the persistence of life under extreme conditions. The paradox is stark. Destruction may also bring revelation, an unveiling of secrets buried beneath Mars's rust-colored crust. From a political standpoint, 3I Atlas forces nations to rethink how they cooperate in space. The event is bigger than any single country's capacity to study. International coordination will be required to share data, allocate telescope time, and prepare observation platforms. Already discussions are underway between NASA, the European Space Agency, and emerging space powers in Asia and the Middle East about forming joint task forces. The potential impact provides an opportunity for unity, reminding humanity that the cosmos does not recognize national borders. Whether nations seize this opportunity for collaboration or retreat into competition will shape the global response and determine the depth of knowledge gained from the event. The business world is watching as well. Companies invested in Mars exploration, whether through robotic missions or long-term colonization planning, must reassess their projections. If the surface is dramatically altered, infrastructure investments may need to be recalculated. Some see opportunity in chaos, predicting that fresh craters could reveal valuable resources like water ice deposits. Others worry that investor enthusiasm will cool if Mars is perceived as too unstable a frontier. The unfolding situation therefore intersects with economics as much as science, influencing decisions about where private capital flows in the next era of space exploration. The object itself remains a subject of intense fascination. Interstellar bodies are time capsules carrying within them the chemical and physical memory of their birthplaces. By analyzing 3I Atlas, scientists may glimpse the conditions of star systems far removed from our own. If the object contains complex organics, as early spectroscopy hints, this could bolster theories that the building blocks of life are common throughout the galaxy. The delivery of such materials to Mars by impact could even echo ancient processes that seeded Earth with the ingredients for life. The irony is striking. What threatens to devastate could also illuminate the origins of life itself, drawing direct lines between interstellar chemistry and planetary biology. In the broader arc of history, 3I Atlas may mark the beginning of a new awareness about interstellar hazards. Humanity has long known about local threats, charting near-Earth asteroids with growing diligence. But the arrival of a destructive interstellar body into the heart of our planetary neighborhood emphasizes that the danger is not confined to our solar system. Galactic dynamics, chaotic and ancient, can reach into our lives at any moment. The notion that planets are islands of stability has been replaced with the knowledge that they are targets in a vast shooting gallery, vulnerable to projectiles hurled from the depths of space. As the object draws closer, anticipation grows. Observatories are training their instruments daily, refining models with every scrap of new data. Simulations of the potential impact run across supercomputers, mapping shock waves, plume dispersals, and orbital debris. Each run adds to humanity's picture of what might unfold, yet uncertainty remains. Will the object strike dead center, carving a fresh scar visible even from Earth's telescopes? Will it graze the planet, skipping past in a near miss that still alters Mars's orbiting environment? Or will gravitational interactions shift its course entirely, sparing the planet but providing a close brush that still teaches much? The suspense is a rare fusion of science and drama played out on the grandest possible stage. If 3I Atlas does collide with Mars, the aftermath will be monitored for decades. The new crater will become a landmark, a site of pilgrimage for every future mission. It will remind explorers, scientists, and settlers alike of the day when Mars absorbed a blow from beyond the solar system. The crater may be studied as intensely as Gale or Jezero, its layers revealing not only Martian history, but also the chemical heritage of another star system. It will stand as a monument to cosmic unpredictability, a scar that is also a treasure trove of information. Even if the object misses Mars, the event will not be forgotten. The near miss itself will provide invaluable data about gravitational interactions, orbital mechanics, and the behavior of interstellar bodies under solar system influence. The lessons learned will refine planetary defense models, ensuring that humanity is better prepared when the next 3I-class body approaches. For the public, the experience of watching the build-up, the warnings from Harvard and NASA, the nightly news stories, the simulations, will leave a lasting impression. It will be remembered as the time when the universe reminded humanity of its vulnerability and its opportunity for discovery. The approach of 3I Atlas is therefore not just an astronomical event, but a cultural and civilizational milestone. It forces humanity to reconcile ambition with fragility, curiosity with caution. Mars, once a distant red dot in the night sky, now stands as a theater for one of the most dramatic cosmic encounters in modern history. The terror and the wonder of this moment will reverberate long after the object has passed or struck, reshaping not only the surface of Mars, but the course of human thought about the universe and our precarious place within it. The continued focus on 3I Atlas has widened into every corner of planetary science, astrobiology, engineering, and even cultural thought, as its trajectory carries not only mathematical predictions, but also existential weight. While most discussions remain centered on its collision probability with Mars, the presence of such a body inside the solar system demands exploration from angles beyond impact physics. Each new observation reveals subtle characteristics that deepen the mystery of its origin and its nature, while also challenging humanity to think differently about the way the cosmos interacts with planetary environments. The approaching encounter is not simply a matter of planetary defense or Martian geology. It is also about deciphering what interstellar bodies can tell us about the galaxy itself. Spectroscopic data collected in the last several weeks has indicated chemical anomalies in 3I Atlas that set it apart from the majority of comets or asteroids observed within the solar system. Certain absorption lines suggest the presence of exotic ices, compounds formed in ultra-cold environments far beyond the frost line of even the most distant solar-type stars. This means the object may have originated in a star system whose protoplanetary disk extended into colder, denser molecular clouds. If so, 3I Atlas could carry within it a signature of galactic processes rarely sampled by humanity. For researchers at Harvard, this provides not only an astronomical curiosity, but a potential breakthrough in understanding how diverse planetary systems form across the Milky Way. Mars, in this context, becomes an accidental stage upon which alien material may be deposited for study. The morphology of the object itself is another source of intrigue. Observations hint that 3I Atlas is not a uniform sphere, but an irregular, elongated body with a tumbling rotation. This chaotic spin could influence how it interacts with Mars's thin atmosphere should it enter on a collision path. A body rotating unevenly may fragment earlier, spreading debris across a wider area. This could transform the nature of the impact from a single catastrophic strike into a more complex bombardment involving multiple craters and shock zones. Such an event would complicate analysis, but it would also enrich it, providing multiple data sets across varied regions of the Martian surface. Harvard scientists emphasize that even in fragmentation, the outcome would still be immensely destructive, though potentially more distributed. The velocity of 3I Atlas creates additional unknowns. At interstellar speeds, objects often possess energy levels that cannot be neatly compared to ordinary asteroid impacts. The heat generated during entry could vaporize vast amounts of material instantly, producing plumes so large they might be visible to the naked eye from Earth. Unlike typical meteor showers or small impacts, this would not be a fleeting streak in the night sky, but a sustained, dramatic event unfolding over hours and days. The luminous display might rival or surpass the great cometary apparitions of the past, leaving humanity not just with data, but with a visible reminder of cosmic power. The psychological impact of such a display could be as significant as the scientific findings, embedding the event into collective memory for generations. Beyond Mars itself, the ripple effects of a 3I Atlas impact would extend into the wider solar system. Dust and debris launched into Martian orbit could create temporary rings around the planet, a phenomenon modeled by NASA's computational teams. These rings, though short-lived, would alter how spacecraft navigate the Martian system, forcing engineers to rethink orbital strategies. Moreover, ejected fragments might escape Mars's gravity entirely, drifting into heliocentric orbit as new asteroids of interstellar origin. This would mean the solar system would inherit pieces of 3I Atlas long after the main event, offering opportunities for spacecraft interception in future decades. Such remnants would be priceless scientific targets, representing tangible fragments of another star system delivered by chance. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on 3I Atlas possibly hitting Mars? We want to hear from you. Thank you for watching and see you next time.